Top 25 Robotics Engineer Interview Questions and Answers. Robotics engineering is one of the fastest-growing fields, combining mechanical engineering, electronics, computer science, and artificial intelligence. Employers look for candidates who possess strong technical knowledge, problem-solving abilities, and hands-on experience with robotic systems. Preparing for a robotics engineer interview requires understanding core concepts such as sensors, actuators, control systems, programming, machine learning, and automation. This guide covers the top 25 robotics engineer interview questions and answers to help both beginners and experienced professionals confidently prepare for interviews and increase their chances of landing a robotics engineering role. 1. What is robotics engineering? Robotics engineering is a multidisciplinary field focused on designing, building, programming, and maintaining robots. It combines mechanical engineering, electrical engineering, computer science, and artificial intelligence to create machines capable of performing tasks automatically. Robotics engineers develop systems used in manufacturing, healthcare, defense, logistics, and space exploration. Their responsibilities include designing robotic hardware, writing control software, integrating sensors, testing systems, and improving robot performance, efficiency, reliability, and safety for various industrial and commercial applications. 2. What are the main components of a robot? A robot typically consists of several essential components including sensors, actuators, controllers, power supplies, and mechanical structures. Sensors gather information from the environment, while actuators create movement. The controller acts as the robot's brain by processing sensor data and issuing commands. The power supply provides energy to the system. The mechanical structure forms the robot's physical body. Together, these components enable robots to perceive, process information, make decisions, and perform tasks efficiently in different working environments. 3. What is the difference between robotics and automation? Robotics involves designing and developing programmable machines capable of performing various tasks, while automation focuses on reducing human intervention in processes. Automation may not always require robots and can involve software or mechanical systems. Robotics is often a subset of automation because robots are commonly used to automate tasks. While automation emphasizes process efficiency, robotics adds intelligence, flexibility, and adaptability, allowing machines to handle more complex operations that require sensing, decision-making, and movement. 4. What are actuators in robotics? Actuators are devices responsible for converting energy into physical movement within a robotic system. They enable robots to perform actions such as lifting, rotating, gripping, or walking. Common types include electric motors, hydraulic actuators, and pneumatic actuators. Electric actuators are widely used because of their precision and efficiency. The choice of actuator depends on factors like speed, force, accuracy, and application requirements. Without actuators, robots would be unable to execute commands or interact with their environment effectively. 5. What role do sensors play in robotics? Sensors allow robots to collect information about their surroundings and internal conditions. They help robots detect objects, measure distance, monitor temperature, identify position, and sense movement. Common sensors include cameras, ultrasonic sensors, infrared sensors, force sensors, and gyroscopes. Sensor data is processed by the robot's controller to make informed decisions and execute actions. Accurate sensor integration improves navigation, safety, precision, and adaptability, making sensors one of the most critical components of modern robotic systems. 6. What programming languages are commonly used in robotics? Several programming languages are used in robotics depending on the application and hardware requirements. Python is popular for artificial intelligence, machine learning, and rapid development. C++ is widely used for high-performance robotic systems due to its speed and efficiency. Java, MATLAB, and Rust scripting languages are also common. Robotics engineers often use multiple languages together to control hardware, process sensor data, develop algorithms, and create intelligent robotic applications that perform reliably in real-world environments. 7. What is ROS in robotics? ROS, or Robot Operating System, is an open-source software framework widely used in robotics development. It provides tools, libraries, and communication systems that simplify robot programming and integration. ROS allows developers to create modular applications where different components communicate efficiently. It supports simulation, navigation, sensor integration, motion planning, and debugging. Although ROS is not an actual operating system, it acts as middleware that accelerates development and helps engineers build scalable, flexible, and advanced robotic systems. 8. What is machine learning in robotics? Machine learning enables robots to improve their performance by learning from data and experience, rather than relying solely on predefined instructions. Through machine learning algorithms, robots can recognize patterns, classify objects, predict outcomes, and adapt to changing environments. Applications include autonomous vehicles, industrial automation, and robotic vision systems. Machine learning enhances robot intelligence, allowing them to make better decisions over time. It plays a crucial role in developing adaptive and autonomous robotic solutions for complex tasks. 9. What is computer vision in robotics? Computer vision is a technology that enables robots to interpret and understand visual information from cameras and imaging devices. It allows robots to recognize objects, detect obstacles, track movements, and inspect products. Computer vision systems use image processing and machine learning techniques to analyze visual data. In manufacturing, healthcare, and autonomous vehicles, computer vision improves accuracy and efficiency. By enabling robots to see and understand their surroundings, computer vision significantly enhances robotic intelligence and autonomy. 10. What is an autonomous robot? An autonomous robot is a robot capable of performing tasks without continuous human control. It uses sensors, software, artificial intelligence, and control systems to perceive its environment, make decisions, and execute actions independently. Examples include self-driving vehicles, warehouse robots, and robotic vacuum cleaners. Autonomous robots can adapt to environmental changes and operate in dynamic conditions. Their ability to function independently improves productivity, reduces labor requirements, and increases efficiency across various industries and applications. 11. What is inverse kinematics? Inverse kinematics is the process of determining the joint angles required for a robot arm or mechanism to reach a desired position and orientation. It is commonly used in robotic manipulators and industrial robots. By calculating appropriate movements for each joint, inverse kinematics enables precise control of robotic motion. This concept is essential in applications such as assembly, welding, surgery, and pick-and-place operations, where accuracy and smooth movement are critical to successful task execution. 12. What is forward kinematics? Forward kinematics calculates the position and orientation of a robot's end effector based on known joint angles and link dimensions. It helps engineers predict how a robot will move when specific commands are applied. This technique is widely used in robot design, simulation, and control. Understanding forward kinematics allows robotics engineers to analyze robot motion accurately and verify system performance. It serves as a fundamental concept for motion planning and robotic manipulation applications. 13. What is a PID controller? A PID controller is a control algorithm used to regulate robotic systems and maintain desired performance. PID stands for proportional, integral, and derivative. The proportional component responds to current errors, the integral component corrects accumulated errors, and the derivative component predicts future errors. Together, these elements provide stable and accurate control. PID controllers are widely used in robotic arms, drones, and industrial automation systems because they improve precision, responsiveness, and overall system stability. 14. What are degrees of freedom in robotics? Degrees of freedom refer to the number of independent movements a robot can perform. Each movable joint contributes one or more degrees of freedom. For example, a robotic arm with 6 joints typically has 6 degrees of freedom, allowing movement and orientation in 3-dimensional space. Higher degrees of freedom provide greater flexibility and dexterity. Understanding degrees of freedom is essential for robot design, motion planning, and determining whether a robot can perform specific tasks effectively. 15. What is path planning in robotics? Path planning is the process of determining the safest and most efficient route for a robot to move from one location to another. It involves obstacle avoidance, motion optimization, and environmental analysis. Algorithms calculate possible paths while considering constraints such as speed, energy consumption, and safety. Path planning is critical in autonomous vehicles, warehouse robots, and mobile robots. Effective path planning improves operational efficiency, reduces collisions, and ensures smooth robot navigation in complex environments. 16. What is SLAM in robotics? SLAM stands for Simultaneous Localization and Mapping. It is a technique that allows robots to create a map of an unknown environment while determining their position within that map. SLAM combines sensor data from cameras, LiDAR, and other devices to navigate accurately. It is widely used in autonomous vehicles, drones, and service robots. SLAM enables robots to operate effectively in environments where pre-existing maps are unavailable, improving navigation and autonomous decision-making capabilities. 17. What is LiDAR technology? LiDAR, which stands for Light Detection and Ranging, is a sensing technology that uses laser beams to measure distances and create detailed three-dimensional maps. In robotics, LiDAR helps detect obstacles, map environments, and support autonomous navigation. It provides highly accurate spatial data even in challenging conditions. LiDAR is commonly used in self-driving cars, drones, and mobile robots. Its precision and reliability make it one of the most valuable sensors for advanced robotic systems. 18. How do you ensure safety in robotic systems? Ensuring safety in robotic systems involves implementing risk assessments, emergency stop mechanisms, safety sensors, protective barriers, and compliance with industry standards. Engineers must identify potential hazards and design systems that minimize risks to operators and equipment. Regular maintenance, software validation, and safety testing are also essential. Collaborative robots require additional safeguards to work safely alongside humans. Prioritizing safety helps prevent accidents, protects assets, and ensures reliable operation in industrial and commercial environments. 19. What is a collaborative robot, cobot? A collaborative robot, commonly called a cobot, is designed to work safely alongside humans without requiring extensive safety barriers. Cobots use advanced sensors and safety mechanisms to detect human presence and prevent collisions. They are widely used in manufacturing, packaging, healthcare, and logistics. Cobots enhance productivity by assisting workers with repetitive or physically demanding tasks. Their flexibility, ease of programming, and safety features make them increasingly popular in modern industrial automation environments. 20. What challenges have you faced in robotics projects? A strong answer should discuss challenges such as sensor inaccuracies, communication failures, hardware integration issues, software bugs, or unexpected environmental conditions. Explain the problem, describe the steps taken to investigate it, and highlight the solution implemented. Employers want to see analytical thinking, persistence, and problem-solving skills. Demonstrating how you overcame technical obstacles while maintaining project goals shows your ability to handle real-world robotics engineering challenges effectively and professionally. 21. What is embedded systems programming? Embedded systems programming involves developing software for specialized hardware devices within robotic systems. These systems control sensors, actuators, communication modules, and processors. Programming is typically performed using languages such as C and C++. Embedded software must be efficient, reliable, and capable of real-time operation. Robotics engineers use embedded programming to ensure smooth communication between hardware and software components. It plays a critical role in controlling robot functions and achieving desired system performance. 22. What is artificial intelligence in robotics? Artificial intelligence enables robots to mimic human-like decision-making and problem-solving abilities. AI allows robots to recognize patterns, understand environments, learn from experience, and adapt to changing conditions. Applications include object recognition, speech processing, predictive maintenance, and autonomous navigation. By integrating AI technologies, robotics engineers create smarter systems capable of handling complex tasks with minimal human intervention. AI continues to drive innovation and expand the capabilities of modern robotic solutions across industries. 23. How do you test a robotic system? Testing a robotic system involves verifying hardware functionality, software performance, sensor accuracy, and overall reliability. Engineers perform simulations, unit testing, integration testing, and real-world operational tests. Testing helps identify defects, optimize performance, and ensure safety compliance. Data collected during testing is analyzed to improve system efficiency and accuracy. A structured testing process reduces failures, enhances reliability, and ensures the robot performs as expected under different environmental and operational conditions. 24. Why do you want to work as a robotics engineer? A good answer should express enthusiasm for technology, innovation, and problem solving. You can explain your passion for designing intelligent systems that improve efficiency and automate complex tasks. Mention interest in combining mechanical engineering, electronics, and software development to create impactful solutions. Employers value candidates who demonstrate curiosity, continuous learning, and a desire to contribute to technological advancements. Showing genuine motivation helps establish a strong connection between your goals and the company's mission. 25. Where do you see yourself in 5 years as a robotics engineer? In 5 years, I aim to become a highly skilled robotics engineer leading innovative projects involving automation, artificial intelligence, and advanced robotic systems. I plan to deepen my expertise in robotic software, machine learning, and autonomous technologies while contributing to complex engineering solutions. Additionally, I hope to mentor junior engineers, participate in research initiatives, and help develop cutting-edge robotic products that create meaningful value for businesses, industries, and society as a whole. Preparing for a robotics engineer interview requires a solid understanding of robotics fundamentals, programming, automation, artificial intelligence, sensors, control systems, and real-world problem solving. Employers seek candidates who can combine technical expertise with creativity, analytical thinking, and teamwork. Reviewing these top 25 robotics engineer interview questions and answers will help you build confidence and communicate your knowledge effectively during interviews. Practice explaining concepts clearly, relate answers to practical experiences, and stay updated with emerging robotics technologies to maximize your chances of securing your desired robotics engineering position.